Okay, now that we know how to process a single dimensional array, let's look at how to do it in multiple dimensions. So I'm going to create a new project. We'll call this process multi-dimensional array. And make it a console application and an empty project like we've been doing. So first things first, I want to make it 64-bit like all my other ones. New platform 64. Close that. Add the property sheet so that it can reference with the OpenCL libraries and header files. Then I'll create a new source file. Call it the same as the project name, process multi-dimensional array. Then I'm gonna copy this from previous tutorial. Okay, so now let's create our multi-dimensional array. I'm going to be using the C++ 11 std arrays. I'm going to make 2 columns and 3 rows. So I need 2 columns, 3 rows. Array equals. Let's give it some dummy data. So include array. Oops. I think there's a bug with the VC12 compiler in that you need an extra set of braces at the end, but oh well. And this is equivalent to the C array like that. No, sorry, like that. Okay. So we need to create a buffer for this. Std, no, not std. CL buffer. That's going to take a context, some memory flags. So I want my kernel to be able to read and write to this. So I'll just say CLmem read write. I want the host to be able to just read from it afterwards. So CLmem host read only, and because I'm going to be passing in data, this, I need to tell it should it use it, should it copy it, should it use that alloc pins memory. I'm just going to say copy. So I need the size of this array. Unfortunately, you can't get it so easy with a multi-dimensional array, so I'm just going to cheat a bit. Oops. Cars equals 2, and then say count equals numbers times calls times. So yeah, I can only do this because they're const, because this does need to be resolved at compile time. So this will be size of int multiplied by count. I need to pass it the pointer to the array start. Cool. So I'll create our kernel, and program and the name of the kernel function, which is process, or will be when I create it, process multi-dimensional array. And I need to make sure to update the name and fix any typos. So it's going to have one argument, and that's just going to be the in and out buffer. So you create a command queue to execute commands. I'm just going to take a context and a device. So I want to execute this kernel. I'll use enqueue nd range. Sorry, this microphone just keeps getting in my way, makes it really hard to type. Kernel. I'm going to have no offset. the global range. So previously we've always just put in one item for this, which is the global amount of work items we want executed, but now we're using multiple dimensions. So I want to pass it the work group dimension sizes, which are 2 and 3, because I've got 2 columns, 3 rows. I don't need any of the rest. And then we're just going to read this back in. Read buffer. I want it to be blocking so that it fully executes by the time this is finished. There's no offset. So this is the size and bytes of the buffer that we're going to read back in, which is just the same as we put in there. And I need to pass in. Close passing.data. Well, it's indirect. And just want the command line window to stay open. So I need to create a file for it. Okay, cool. So as usual, it needs to start with kernel. Oh, and just to show you, you don't actually need the underscores in front of the kernel or memory keywords like global. I would normally advise doing it though, but I'm just going to show you that you don't actually need to in this example only. It just makes it easier if you do. Process multidimensional array. So global data. So what's my outcome? So I'm going to need to set the element to, oh, I don't know, I'll just something simple and multiply it by 2, but now we need to work out what is this element going to be. And you do that with this little, well, it's not really a trick, just a bit of maths. So you get the ID of the row, multiply it by the size of the first dimension, and then you add the ID in the first dimension as well. 0. I'll explain that now. Oh, come on. Yeah. Alright. So this is how our memories, it doesn't actually look like this because in reality it's all contiguous, so it'll go 0, 1, 2, 3, 4, 5, but for illustrative purposes it looks like this. So we get the ID of the second dimension, so this is the first dimension, this is the second dimension, so we're currently at 0, so we do 0 times the size, which is 2, the size of the first dimension. So 0 times 2 is 0, plus the ID in the first dimension, which is 0, so we end up with 0, so we get an ID of 0. And then we move 1 across, get global ID is still 0, so that's going to return 0, and then plus the ID of the first dimension, you get 1. And then here we've got 1 for the ID of the second dimension, so we do 1 multiplied by the size in the first dimension, which is 2, so 1 times 2, plus the ID in the first dimension, which is 0, so you get 2, and continue like that. Copy the size, oops, wrote it down here. Oops. Okay, cool. So with any luck, I will get a array with, oh, oops. That's because I didn't set this as the startup project. Okay. So like I was saying, hopefully every element in this multi-dimensional array has been multiplied by 2. Doesn't know what create program is. It's because I need to add as a reference. Try that again. Okay. So hopefully I get everything multiplied by 2. 2, 4, 6. Woohoo! Okay, yeah, not really sure what else to talk about. That wraps it up. Cheers.